Go ahead and get some notebook paper out in the meantime so you can just write these examples down as we go through them. And there's an extra one I want to start with that's not in the PowerPoint, but let me get into what we're talking about. So we're looking at section 3.3, which is on dividing polynomials. So take good notes on this and follow along as we go through. It's a little overwhelming, a little intimidating maybe the first time you go through it, but with a little practice, I think you'll get it. So far we've added polynomials, we've subtracted polynomials, we've multiplied polynomials anytime we distribute or FOIL. The only thing we really haven't done much with is dividing polynomials. And there's really two main types of division that we're going to work with. One is called long division, and I want to start with an example of long division that you may have done back in elementary or middle school when you first learned to do division. So let's look at something simple. Let's say we want to take 5 and do long division and divide it into 628. I don't know, I'm making this up. Let's see how this turns out. So there was a little acronym called DMSB, and what this stood for was divide, multiply, subtract, and bring down. And that's the process. This is sort of the algorithm you want to follow every time you do a long division problem. And you would have done it with numbers in the old days before somebody gave you a calculator, but we're still going to use it when we do polynomials. So let's work with numbers first, and let's just remind ourselves of what this involves. So we're going to take 5, we're going to divide it into 6. That's the first part of the algorithm. 5 divides into 6 one time. So I'm going to multiply. That's the next part. 1 times 5 is 5, and then the S is subtract. So I'm going to subtract. 6 take away 5 is 1, and then we're going to bring down. So I'm going to bring down the 2, and then we're going to repeat the process. 5 goes into 12 twice. We're going to multiply. 2 times 5 is 10. Then we're going to subtract. That gives me with 2. Then we're going to bring down. So there's the 8. Repeat it again. 5 goes into 28. 5 times. 5 times 5 is 25. We're going to subtract. We get 3. Bring down. 5 goes into 33. 6 times. 6 times 5 is 30. And then we're going to subtract. Now, how do we know when we're done? Well, if we get down to a number that we can't say 5 goes into that number and there's nothing else to bring down unless we started getting into decimals, that means this 3 is going to turn out to be our remainder. And when you were in elementary school, your teacher might have said, okay, so your answer is 1,256, and you might have put the R3. We're a little more sophisticated than that. Instead of using R, the way we're going to write our answer is 1,256 plus 3, which is left over, divided by what we were dividing by, 5. So in other words, 3/5 of a whole was what was left over, and that's going to be our answer. Okay? Now, let's look at the example that's in the PowerPoint. So if you have the PowerPoint there, we're looking at example 1 in the PowerPoint, which involves looking at long division using polynomials. So let's take a look at that. So I'm going to go ahead and write it out here so you can see the question. So we're going to divide. And it says to divide using long division. So we've got x plus 3, and we're going to divide that into x squared plus 10x plus 21. So the process is the same. We're going to follow that divide, multiply, subtract, and bring down algorithm. So all we have to look at with these is the very first term. So x goes into or divides into x squared how many times? In other words, x times what would give me x squared? That's another way to think about it. Like if you factored an x out, what would you multiply it by to get x squared? And that would be x. I'm going to put the x above the 10x term because I always like to keep the terms lined up. So since that's a first degree term, I'm going to put the x above that first degree term. Then we're going to multiply. X times x is x squared. Notice those two terms are the same. They should be, but I have to distribute. So I've got to do x times 3 as well. So that's going to give me plus 3x. Then we need to subtract. Here's the biggest mistake students make is they do this. They forget that that negative sign has to be distributed to both of these terms. So I'm going to put parentheses around it. Don't forget those parentheses. It's going to make a big difference. So we've got x squared minus x squared, because that's going to turn into an x squared, a negative x squared, so those are going to cancel out, which is what we want. The 3x also becomes negative. So we've got 10x take away 3x, which gives us 7x. And then b is bring down, so we're going to bring down the positive 21. And now we're going to do it again. X times what gives me 7x? In other words, what's 7x divided by x? And that would be positive 7. So I'm going to put a plus 7 up here. Then we're going to multiply. 7 times x is 7x. 7 times 3 is 21. So we're going to add that. And then we're going to subtract. Remember that negative sign has to go to both, so we're going to put parentheses around it. And notice that the 7x becomes negative, so 7x minus 7x cancels out. The 21 also becomes negative. 21 minus 21, those also cancel out. And I'm left with 0. So this time I have no remainder. So my quotient is going to be x plus 7. That would be the quotient after we do the division. You may have noticed that x squared plus 10x plus 21, if you factored that, that would have factored into the product of x plus 3 and x plus 7. That's not a coincidence. That's because if you FOIL those out, you get x squared plus 10x plus 21. And so when we divide x squared plus 10x plus 21 by the x plus 3, we get the other factor of x plus 7. Won't always work out that nicely, but if there's no remainder, that's the way it should work out. Okay, let's take a look at example 2 in the PowerPoint. So we've got a little bit more going on here. We've got 5x to the third plus 6x to the fourth minus 5 plus 3x divided by 3x squared minus 2x. So the first thing I hope you observe is that it's not written with the division bar. So if it's written this way, let's write it with the division bar. I think it's much easier to go through the algorithm that way. So what's going to go under the division bar? Well, that's the thing that you're dividing. Do you also notice these are out of order? So you want to always write these in descending order. So we're going to start with 6x to the fourth plus 5x to the third. Do you notice that there's no x squared term there? So we need what's called a placeholder there, and that's the x squared. So I'm going to put a 0x squared. Do not skip those placeholders. They're going to be very important. And then we're going to continue, plus 3x minus 5. So that's descending order. Now what goes in front? That was the thing we were dividing by. So that's 3x squared minus 2x. And again, there's no constant term at the end, so I need a placeholder there, plus 0. Even if it's at the end, don't leave out that placeholder. So let's go through the algorithm. Remember, it's divide, multiply, subtract, and bring down. So start with the division part. We only have to look at that first term. 3x squared times what would give us 6x to the fourth, and that would be 2x squared. And so I'm going to write that above the x squared term. Remember, I like to keep those lined up. So 2x squared times 3x squared is 6x to the fourth. 2x squared times negative 2x is negative 4x cubed. 2x squared times 0 is 0x squared. We're going to subtract, and remember to use parentheses here. The 6x to the fourth becomes negative. 4x cubed becomes positive. 0x squared, you could say, is negative. 6x to the fourth minus 6x to the fourth, those cancel out. 5x to the third plus 4x to the third is 9x to the third. 0x squared minus 0x squared is still 0x squared. And then b is bring down. So we're going to bring down the 3x. And then we're going to repeat the algorithm. Can I multiply 3x squared by something that will give me 9x to the third? And that would just be 3x. Then we're going to multiply. 3x times 3x squared is 9x to the third. 3x times negative 2x is negative 6x squared. 3x times 0 is 0x. We're going to subtract. Again, do not forget the parentheses. Distribute that negative sign, so the 9x cubed becomes negative. 6x squared becomes positive. 0x you could think of as negative. The 9x cubes cross out. What's 0x squared plus 6x squared? And then 3x minus 0x, of course, is 3x. and then bring down, so bring down the 5. How do we know when we're done? Well, if we can go one more time without dealing with fractions, then we'll go one more time. So can I multiply 3x squared by something to get 6x squared? And the answer is I can multiply that by 2. So I'm going to have a plus 2 at the end up here. 2 times 3x squared is 6x squared. 2 times negative 2x is negative 4x. 2 times 0 is 0. We're going to subtract again. Don't forget the parentheses. 6x squared minus 6x squared. Those cross out. 4x rather becomes positive. So that gives me 7x. Negative 5 minus 0 is still negative 5. Can I multiply 3x squared by something to get 7x? No, I cannot, since it's a lower powered term, so this is going to be the remainder. So let's go ahead and write out the answer. So it's going to be 2x squared plus 3x plus 2, and then take your remainder and put it over, so plus your remainder over what you were dividing by. And I did not include the placeholder there with the remainder term. You could or not, it wouldn't make a difference, but this is going to be our final answer. Let's switch gears a little bit. In the PowerPoint, we're talking about a different type of division called synthetic division. And so whenever you're working with these problems, you're going to either have to use long division or synthetic division to divide. Synthetic division, I think you'll like. It's a lot quicker, tends to be a little bit easier, less tedious. But the trick with synthetic division is it can only work when you're dividing a polynomial by a linear factor, x minus a number or x plus a number. So when you're dividing by a linear factor, that's when you can use synthetic division. We couldn't have used it in the last example because we were dividing by a quadratic factor, the x squared. But anytime we're dividing by a linear factor, we can use synthetic division. So in the PowerPoint, let's take a look at the question they ask us to try. They've got 5x cubed plus 6x plus 8, and then dividing by x plus 2. So there's a little sort of arrangement we're going to follow here. And the way you're going to do this is you're going to put a little half box on your paper. And the number that goes inside that little half box is going to be the 0, I guess you would say, if you were to set x plus 2 equal to 0. In other words, if I set x plus 2 equal to 0 and solved it, I would get negative 2. That negative 2, that's what's going to go in the box here. You just remember it's the opposite of whatever that number is. So if it's x plus 2, it's going to be negative 2 in the box. Then we're going to put the coefficients of the polynomial that's being divided. So we're going to have a 5. You notice again we're missing a term. There's no x squared term, so I need to put a 0 there for the placeholder. Placeholders still apply. And then 6 and then 8. Leave a little room on your paper. Leave a line underneath that. And then first step is we're going to bring down the 5. So negative 2 times 5 is negative 10. Make sure you see what I did. I brought down the 5. I multiplied what was in the box times the 5. I got negative 10. Then I'm going to add these two numbers together. 0 plus negative 10 is just negative 10. Then I'm going to multiply again. Negative 2 times negative 10 gives me 20. I'm going to add the 6 and the 20 together. I get 26. Then I'm going to do it again. Negative 2 times 26 is negative 52. I'm going to add 8 and negative 52. I get negative 44. That's going to be our remainder. So the actual quotient, we write it out. It's 1 degree lower. So if we were dividing by 5x, or if we were dividing 5x cubed, this is going to be 5x squared. And then minus 10x plus 26. And then we're going to put negative 44 over what we were dividing by, which was x plus 2. And that's our final answer. Okay, in the PowerPoint, there's another example for you to try. So maybe pause the video for a minute and give this one a try. They're asking us to divide x cubed minus 7x minus 6. We're going to divide that by x plus 2. And so in our box here, this is x plus 2. It's just going to be negative 2. Notice we need a placeholder again. So we have 1, 0, -7, -6. Make sure you see where that 1 came from. That was the coefficient on the x cubed term. Leave a space and then draw a line. Bring down the 1. -2 times 1 is -2. 0 and -2 is -2. -2 times -2 is 4. -7 and 4 is -3. -2 and -3 is 6. -6 and 6 is 0. So this one did not have a remainder. The final answer, though, we need to write it out. Since this was x cubed that we were dividing by, this is going to be what? 1x squared minus 2x minus 3. And that's our final quotient. Okay? The next example in the PowerPoint, they're asking us to solve an equation, and they're telling us that 3 is one of the zeros. Let me write this out. So the directions ask us to solve the equation. So the equation is 2x cubed minus 3x squared minus 11x plus 6 equals 0. Now, if we could factor this, it's 4 terms. If this would group factor, we could use that and solve it that way. But unfortunately, this does not group factor. So what we're going to do, they told us one of the zeros. They said, given that 3 is a 0 of the polynomial f of x equals 2x to the third minus 3x squared minus 11x plus 6. So there's a factor theorem that tells us that if 3 is a 0 of that polynomial, that means if you were to plug in 3, you would get 0 for the y value. And likewise, if we were to do synthetic division, we should get 0 as a remainder. So we're going to use synthetic division, and we're going to use 3 as the number in our box. Now, careful, it's not -3. Had they given this to us as a factor, it would have been x minus 3 because positive 3 was the 0. So if they give you the 0, that's what goes in the box. When they give it to you as a factor, like x minus 3 or x plus 2, that's when you have to change the sign. But they told us 3 was the 0, so 3 is what goes in the box. We're going to label 2, -3, -11, and 6. No placeholders needed this time. Drop down the 2. 3 times 2 is 6. -3 and 6 is 3. 3 times 3 is 9. -11 and 9 is -2. 3 times -2 is -6. And we get 0 as a remainder. That's a good thing. That's what we expected. If we got something else, we'd need to go back and check our math there. So if we write all this out, this is going to be 2x to the second power, because remember we were working with a cubic, so it drops by 1 degree when you use synthetic division, plus 3x minus 2. Now, the question asked us to solve the original equation. So we could solve this and find the other zeros by setting this equation equal to 0. And if you have a question like this in the homework, it'll be something at this point that you can factor. And so we have a trinomial here. It does factor. Think about how you could break this down. The first terms have to multiply to 2x squared. 2 is a prime number, so it's got to be 2x and x. The last terms have to multiply to a -2, so that means it's got to be 2 and 1. We just have to find the right combination that when we FOIL it would give us positive 3 in the middle. I believe if we put the 2 here, that'll make the outside term a 4, and then if we put the 1 here, that makes the inside term a 1. 4 take away 1 gives us 3. So that means we want the outside term to be the positive and the inside term to be the negative. So if we set both of these equal to 0 using the zero product property, we'll get our other solutions to the original equation. So we're going to add 1 there. We get 2x equals 1, so x equals 1/2. Subtract 2, we get x equals -2. And so in your final answer, don't forget to include all of the zeros. So the third one was the one that was given to us, the x equals 3. And those are the 3 solutions to the equation.